Somewhere past the edge of everything our sun can touch, a machine we built in 1977 is still moving. A message sent today, traveling at the speed of light, reaches it tomorrow. It is the farthest our eyes have ever reached, the first to look back, and watch our entire world shrink to a single point of light. And at this moment, it is completely alone in the vast dark of space.
This is the story of Voyager 1, where it came from, where it is right now, and where it will still be long after you and I and everyone we have ever known is gone. Voyager doesn't just last, it sees. The sun dying, new stars being born and burning out, galaxies colliding, with Voyager as the silent witness to everything that comes after us. Stay to the end, and you'll watch the entire future of the universe through one machine's eyes, and see exactly what we left out there in the dark.
In the summer of 1977, a Titan rocket thundered into the sky from Cape Canaveral, carrying a spacecraft no larger than a small car. Its name was Voyager 1. Its twin, Voyager 2, had already launched just weeks before. The mission seemed straightforward. Fly past Jupiter, fly past Saturn, take some photographs, send the data back to Earth, and then go quiet. Scientists expected the spacecraft to survive for perhaps 5 years, maybe a little longer if everything went perfectly. There was no plan for it to come home. No recovery mission. No return journey. Voyager 1 was built for one purpose: to keep going. And the moment it rose above that launch pad, it began a journey that would carry it farther from Earth than anything humanity had ever built. What nobody could have imagined that day was that a spacecraft designed for a short planetary tour would survive for decades. But here is the part that makes Voyager possible at all. A spacecraft this small could never cross a solar system this vast on its own power. It didn't have the fuel. It never did. So it cheated, using a trick of gravity and a piece of cosmic luck that comes around only once every 175 years. In the late 1970s, the outer planets drifted into a rare alignment. Jupiter, Saturn, Uranus, Neptune, all strung along one side of the sun, like stepping stones laid across the dark. And that alignment meant a single spacecraft could leap from one to the next, swing past a giant planet, steal a sliver of its motion, and be flung onward, faster and for free. They call it a gravity assist. Voyager wasn't driven across the solar system. It was thrown, hurled from world to world, gathering speed with every pass, until it was moving fast enough to escape the sun entirely. No human machine had ever been given that kind of push, and it would never slow down again.
In 1979, Jupiter rose in Voyager's cameras, and it was enormous. A world so large it could swallow 1,000 Earths whole. Its surface was chaos, storms wider than our entire planet turning slowly, some of them raging for centuries. The Great Red Spot alone is a hurricane so big you could drop 3 Earths into it and still have room to spare. But the thing that stopped scientists cold wasn't the planet. It was one of its moons. As Voyager passed a small moon called Io, its cameras caught something no one had ever seen anywhere but home. Volcanoes. Erupting. Throwing plumes of sulfur hundreds of kilometers into space. A living, molten world out there in the freezing dark. The first active volcanoes ever found beyond Earth. Then Jupiter did its job. Its gravity grabbed Voyager, slung it around, and launched it onward towards Saturn. And in 1980, Saturn filled the frame. Those famous rings up close, resolving into thousands upon thousands of individual ringlets, waves, and gaps, all made of ice and dust, all shaped by gravity. But Voyager had one last target it wanted more than any other, a moon called Titan, bigger than the planet Mercury, wrapped in a thick orange haze so dense you cannot see its surface at all. The only moon in the solar system with a real atmosphere. To get close to Titan, Voyager had to give something up. The same path that carried it past that strange, shrouded world also bent it upward, lifting it off the flat plane with a planet's orbit and pointing it out, away from everything. After Titan, there were no more worlds ahead of it. Only the dark. Only distance.
Bolted to the side of that spacecraft is the strangest thing humanity has ever sent into space. It isn't a camera. It isn't an instrument. It's a message. A golden record. A disc plated in gold, carrying the sound of who we are. A human heartbeat. A mother's kiss. Rain. Thunder. Ocean waves. The song of a whale. And music. Bach and Chuck Berry, and songs from cultures all across the earth. Greetings spoken in 55 different languages. Photographs of our cities, our children, our world. And carved into its cover, a map. The location of our sun, drawn against a handful of distant pulsars, so that anything that ever finds it could follow the trail back to us. We didn't send it because we expected an answer. We sent it the way you might write a letter, seal it in a bottle, and throw it into an ocean with no far shore. Not because someone will read it, but because it mattered to say it at all. To leave behind one small piece of proof that we were here, that we lived, that we looked up at all that emptiness, and we reached out anyway. In 1990, Voyager did something it would never do again. It turned around. For one last time, it aimed its cameras back the way it had come, back toward the tiny cluster of worlds it had left behind. And from 6 billion kilometers away, it took a photograph. In that image, Earth is not a planet. It's not a globe of blue and green. It is a single dot. One pale, faint speck of light, smaller than a pixel, caught by chance inside a stray beam of sunlight. That dot is everything. Every person who has ever lived. Every king and every war. Every love story. Every prayer. Every name ever written down. All of human history, folded into one flickering point of light in an ocean of black. Carl Sagan called it the pale blue dot. And then, to save the last of its power for the long road ahead, Voyager shut its cameras off. It would never take another picture. From that moment on, it stopped looking back. For the next 20 years, Voyager fell outward through the sun's own kingdom, a vast, invisible bubble blown by the solar wind, stretching far, far beyond the last planet. And then, on August 25th, 2012, everything changed. The stream of particles pouring out from our sun suddenly dropped away, and in its place rushed something else, a flood of cosmic rays coming from the deep space between the stars. Voyager didn't see a wall. There was no line drawn across the void, no sign, no border. But its instruments felt it. It had crossed the heliopause, the true edge of the sun's reach, the boundary where our star's influence finally ends and the rest of the universe begins. For the first time in the history of life on Earth, something we had made was no longer inside our solar system. It was out in interstellar space, out among the stars. A tiny machine from a small blue world, now sailing the dark between suns.
Which brings us to right now, to this year. Because in November of 2026, Voyager crosses a line that no object built by human hands has ever crossed before. One full light day from Earth. nearly 26 billion kilometers away. Think about what that means. Light, the fastest thing in the universe, now takes an entire day just to reach it. Send a signal to Voyager this morning, and it doesn't arrive until tomorrow. If it answers, we won't hear it until the day after that. Every conversation with it now stretches across days. And it is still talking to us, still sending back data across that impossible distance on a radio transmitter weaker than the little light bulb inside your refrigerator. A whisper so faint that catching it at all requires the largest antennas humanity has ever built, straining to hear a signal that has been traveling for almost a full day before it reaches the ground. Nearly 50 years after it launched, 26 billion kilometers away, and it is still reaching back toward home. But that voice is fading because Voyager is running out of time. Voyager runs on heat. Deep inside it, a small amount of plutonium slowly decays, and that warmth is turned into electricity. But a little more of it fades every single year. And so, for decades, the engineers on Earth have been making an impossible choice, over and over again. One by one, they've been switching Voyager off. A heater here, an instrument there, turning out its lights room by room, just to keep the last few systems alive a little longer. And sometime in the 2030s, they will run out of things to turn off. The power will drop too low. The last instrument will go dark. And when that moment comes, Voyager won't explode. It won't crash. It won't fall out of the sky. From here on Earth, it won't even look like dying. It will simply stop answering. One day, we will send a signal, and nothing will come back. The most distant traveler we have ever built will fall silent and keep moving anyway, still carrying its golden letter, still sailing outward, whether anyone back home is left listening or not. And here is where the story stops being about a spacecraft and starts being about time. Because with its radio silent, Voyager becomes what it was always destined to be, a message in a bottle, drifting between the stars. In about 40,000 years, it will pass its first one, a small, dim red star called Gliese 445. Though pass is a generous word. Even at its very closest, Voyager will still be more than a light and a half away from it. Out here, the emptiness is so total, so complete, that even a machine moving 61,000 kilometers an hour barely seems to move at all. By then, everything will have changed back home. No one will be tracking it anymore. No one will remember the names of the people who built it. The country that launched it may be long gone. The whole of human history might be nothing but a faint memory, if it is remembered at all. But the record will still be there, riding on its side, its map still pointing the way home, to a home that may no longer exist. Now, push time forward again, not thousands of years, billions, 4 billion, 5, and the sky itself begins to change. The Andromeda Galaxy, our closest great neighbor, a trillion stars strong, has been falling toward the Milky Way for billions of years. And now, at last, it arrives. The two galaxies meet. They pass through one another, tearing at each other with gravity, until slowly, over hundreds of millions of years, they merge, becoming a single, enormous new galaxy. It is the most violent, most beautiful event our galaxy will ever face, and Voyager is inside it. Somewhere in that slow collision, impossibly small, our little probe drifts on. It cannot see any of it. Its eyes went dark billions of years before. It is the witness that can no longer watch. It doesn't know the sky is on fire around it. It doesn't know anything at all. It simply keeps going, the way it always has. Because Voyager was never traveling towards something. it was only ever traveling away. The universe today is about 14 billion years old. 10 trillion years is almost 1,000 times longer than that. And by then, the age of starlight is over. The bright stars, the big, hot, brilliant ones, have all burned out long ago. Even the sun is nothing now but a cold, dead cinder. Only the faintest stars remain, tiny red dwarfs, burning their fuel so slowly they can last for trillions of years. And one by one, even those flicker out. New stars stop forming. The galaxies fill with dead embers and drifting remnants. The lights are going out across the entire universe, and they are not coming back on. The sky grows dark and empty and quiet. And if Voyager is still out there, cold and silent and untouched in the vacuum, where nothing can rust or rot or decay, then something extraordinary is now true. This one small machine, built by hand on a summer afternoon in 1977, is older than almost every star still burning in the sky. It has outlived the sun. It has outlived the stars we were born beneath. And it is still carrying a human heartbeat, recorded on a single day on Earth, long, long after the last person who could have heard it turned to dust. The universe is almost too vast to imagine, almost too old to measure. And the smallest thing we ever built is going to outlast nearly all of it, drifting on long after we're gone as proof that we were here and that we dared to reach. And then, finally, the timeline stops being history and becomes theory. On spans of time so vast they barely have names, even matter itself may not survive. If the physicists are right, then the very atoms Voyager is made of will slowly, slowly come apart. Over unimaginable stretches of time, everything dissolves. The dead stars, the cold planets, the golden record, and Voyager itself, fading particle by particle into nothing at all. In the end, even the universe forgets. But that ending is so far away that between now and then lies more time than has ever existed in the entire history of everything. And for all of it, for trillions upon trillions of years, this stays true. We were a small and fragile species. We woke up on one tiny world, lost in a universe far too enormous to ever cross. And instead of looking away, we looked up, and we reached out anyway. Voyager is that reach, made real, still moving, still carrying us, still whispering into the dark, to no one and to everyone at once, the only thing it was ever meant to say. We were here. We existed. And once, we dared to reach for the stars.